Hello, welcome to Zigmatech Learning Hub. I will be your instructor for physics. For this class, we are going to be taking our exercises from Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell and get updated on new videos. Are you ready for this class? Okay, let's get started. Welcome to physics class, and today we want to talk about work. The way we talk about work in real life and in other aspects is not the same way work it is in physics. When we are talking about work in physics, we are talking about a force and distance in the same direction. So when your force is applied in the same direction as the distance that it has taken, then we say that the work is done and is positive. So we can have a positive work, we can have a zero work, and we can have a negative work. When the body moves in opposite direction to the force applied, then we say that the work is done in the negative, the work done is negative. So when the work is moving, when the force on the body is in the same direction as the body is moving in a certain distance, we say that work is positive. And when you are carrying any load and you are not moving anywhere, we say that zero work is done. These are many more as we consider by the end of this lesson, you should be able to define work and the cases of application of work, and then two, you solve problems on work. And that is why we term it part one, because in part two, we are going to talk about power and energy transformation. Now, work can be done in different ways. In push and in pull, work is done. So if you apply energy on the body, no matter how you apply the energy, if the body does not move, all your work done in physics is zero, because there is no distance recorded by the object which the force is being applied on. However, if you apply a force on a body and the body is moving in the opposite direction of the force applied, we say that the work done is negative. So the screen, you are seeing a man pushing a body and this one pulling it, and the two of them are moving in the same direction. And if for any reason the body moved from one point to the other, we say that work is done. Now look at this one. Work is done. Why? Because the young man started from a point and moved a distance of 5 meters and in the same direction. We now say that work is done because even time is applied. But then remember, when time is considered for a work, we are not talking about work anymore, we are talking about the power. That means the rate of work done, and that is power. Now, we are going to look at work in different cases. Like we said before, we said that work is force times distance. Remember, we are using S as our distance in this case. So we are going to look at different cases where force is applied. Let's look at the first part, which we have the question on the screen. A constant force. However, remember that these forces, there must be a constant force. The force must not be changing. So for us to consider the force in this level, if we have a force of 40 Newton and on a body initially at rest, so if a body is at rest, it means that U is 0. Initial velocity is 0, and acceleration is recorded, which is 0.1 meters per second squared. And we are asked to find the work done if the time taken is 4 seconds. Now we know that work done is force times distance. But if you look at all this, we are not given distance. Distance was not given. But remember what we learned in our previous class in motion, or linear accelerated motion. We said that distance is equal to this. We said that this is distance. Therefore, I'm going to carry this and put here. Remember that we have to find distance. Remember that u is 0. So this is going to be 0. We have a times. A there is the 0.1. Then times 4. I mean, the time is 4, which is this time, all squared. So I'm going to have S is equal to 1 over 2 times 1 over 10 times 16. So this is, distance is going to be 16 over 20, which is 8 over 10, and which is 4 over 5. So distance is going to be 4 over 5. Now, if distance is 4 over 5, I'm going to put it here. Remember, it is in meters. I'm going to say that work done is 40 times 4 over 5. 5 is F1. 5 into 8 into 40 is 8. So we have that the work done is going to be 8 times 4 is going to be 32 joules, because the SI unit of work is joules, and that is why we have this as joule, as the work done by this question. Now, there is another branch of work done whereby a force is applied on a body at an angle. Now, let's look at a question, because see, if you look at this picture, we see that this is a force applied, and this is the angle, and this is the distance traveled. Let's find what happened. We said that a boy drags a bag of rice along a smooth horizontal floor with a force of 2 Newton applied at an angle 60 to the horizontal floor. The work done after a distance of 3 meters. So let's assume this is a bag of rice. Can be. This cannot be. Let's assume this is a bag of rice, you know, and this is the horizontal floor. Then the boy attached a rope at this point at 60 degrees. And this is the force the boy is using to push. And this is 2 Newton. The boy is pushing it at this point. And then this ball has started somewhere, and it is to cover a 3 meters to get to another point. Now, we are asked to find the work done after a distance. All right, in this case, whenever a force is applied at an angle, that force must be resolved to find its effective force. So we are going to resolve this. And the force we need is not the force that is going upward. Therefore, we are not going to use the vertical component of the force. We are going to use the horizontal component of the force, because the essence is that this bag of rice must move from here to this point in a straight line. Therefore, I'm going to resolve this force on the horizontal projection on the horizontal. And I'm going to consider Fx. So if I'm going to use adjacent over hypotenuse. So I'm going to say that sine adjacent over hypotenuse is going to be cos 60 degrees is going to be Fx, that is the horizontal component of the force, all over 2, which is the adjacent. All right? So when I clear this fraction, I'm going to have Fx is going to be 2 cos 60 degrees. And this is the force the boy is applying, which is the most effective force that will ensure that this bag of rice is moved along that distance. And that's the most effective. So the work done is, work is defined as force in this direction, force in the component of the force in the horizontal direction, times the distance which the boy has to drag it, and that is S. And the distance is given as 3, and this one is given as this. So I'm going to say that work is given as 2 cos 60 times 3. And this is going to be 2 times 3 is 6. Cos 60 is 0.5 times 0.5. Then we are going to say that work done is going to be 3 joules. So the boy applied 3 joules in order to move the bag of rice at 3 meters in the horizontal component. Now, this is another case of work. Remember, we did the first one. Now, we have another one whereby friction is there. Look at that ant. He's trying to push that block. And initially, his force couldn't help him to push it. And his persistence continued. And he was able to push in that direction. But look at that red arrow. The red arrow is saying that there is something moving. And that is the frictional force, which is opposing the movement of his force in order to move this block. Therefore, we are looking at work and friction. So when friction is considered, what then do we do? Because even this boy, when he was pushing this bag of rice, there was a friction opposing his force, but it was not considered at the point. But now we want to look at a question where frictional force is considered. Now, a box of 40 mass is being dragged along the floor by a rope inclined at 60 to the horizontal. The frictional force between the box and the floor is 100 Newton, and the tension on this rope is 300 Newton. How much work is done in dragging the box through a distance of 4 meters? All right. It's a box, so I'm going to use this to represent the box, and this is my horizontal ground. And this is the rope, and this is the angle. The angle is 60 degrees. This is the box. Okay, the box is 40 kg. Now, in this case, there is a force opposing the movement, which is 100 Newton. It is moving in this direction. Then the rope has a tension. There is something called a tension. Anytime you see tension, it is force. Force applied through a rope is called tensional force. And how much work is done in dragging the box through a distance of 4 meters? So let's assume that the box is moving from here in this direction in 4 meters apart. What do we do? Now remember that whenever a frictional force is applied, not even issue of frictional force, this is a vector. Something is intending to move in this direction, but there is something opposing it. What we are looking for is the change of the force. So we are going to subtract the force. Now, I have to resolve this force. To resolve this force, I'm going to say that the force in the horizontal component is going to be 300 times 60 times cos 60. And that is going to be, Fx is going to be 300 times cos 60 is 0.5. So Fs is going to be 150 Newton. So that is the force it's using to move in this direction. But there is a damping. There is a restriction, and that is by this force. So I'm going to say change in the force is going to be 150 minus 100. So the change in the force is going to be 50 Newton. So this is the work, the force I need. Then work is defined as force times distance. And the force is 50 times distance is 4, and this is going to be 200 joules. And that is the answer to this question. Now, we say work and equation of motion. We've treated this question earlier. So that was the first question we treated. We are talking about the work and the equation of motion, whereby we consider that the distance is not given, but the distance was given as the S equals to UT plus half AT squared to solve the problem. Now let's look at work and the force distance, the graph, force displacement graph, so that when you have a graph, this is a graph, and Cartesian graph, this is force against displacement. We say find the work in this case. Whenever you are given a graph, now look at what I said. It said work done in is area under the graph. So area under the graph is everything on this part, and that is a triangle. So the triangle is base times height. So half, so the work here is going to be half times base. Base is 20 meters times height. Height is 100. Therefore, this is 10. The work done is 1,000 joules. And that is the essence. Thank you for being part of this class. Remember that we are going to check more exercises from Examguide app. So we have this Examguide app here. This is UTME. It said a ball of mass 100 grams falls from a height of 5 meters onto a floor and rebounds to a height 3 meters. What energy is lost in the process? Energy? Energy. Work is energy, remember. Work is energy because they share, technically, mathematically, work and energy are the same thing. So in this case now, we say that it is falling from a height and onto a floor and rebounds. So in this case, I'm going to say that it's a change in the energy. The one, see, this is the mass, 100 grams. When it falls down, it's moving in this direction. And rebounding means it's going to, from here, 100 grams, goes up here. This is 5 meters and this is 3 meters. So what is the change? This is the change. So what we are looking for is the energy lost. So what is the energy lost? Because it was supposed to come back to this place where it started. This is where it started, which is from here is 5. Then it gets to this point. So it hits here, but it couldn't go back. So what's the energy lost on the process? The work in this case is going to be the gravitational potential energy, which is gravitational potential work, according to me. So what I'm going to do is I'm going to say that there is change in potential energy, which is going to be mgh1 minus mgh2. So h1 is 5, h2 is 3. So I'm going to say the mass is 0.1, sorry, 100 divided by 1,000 is 0.1 kg. Yes, I'm going to use 0.1 kg. And g is constant, which is times 10. Then height, the first height is 5 meters. So I'm calling 5 minus, the second height is 3 meters. So there is energy loss. Change in the potential energy is the loss in the, is the loss of the impact, or the what energy lost. So I'm going to have 1 times 2, which is equal to 2 joules. So the option A is the answer because energy lost is 2 joules that was lost in order to come back to where it started. Now a mouthpiece, this one. A mouthpiece of a telephone primarily converts sound energy into, or sound energy. Whenever you are talking to your microphone, you are converted into electrical. It can't be mechanical because that's not what earpiece does. It doesn't have anything to do with mechanical. Chemical, no, and heat, no, that's electrical. All right, the first start, okay. Coincidentally, we solved this thing on the lesson. You can check it up, and it was solve this, okay. All right, let's solve. It wasn't really, I was mistaking it for a question. Let's try it. Oh, sorry. Let's solve this one. They said that a force of 200 Newton starts a body from rest. Okay. The force is 200 Newton. Starts a body from rest and accelerates in accelerate it uniformly. So the body was at rest, u is going to be 0, and accelerate it 2 meters per second square. For 4 seconds, time is 4 seconds. We say determine the work done by the force. The work done. All right. Work is force times distance. And for us to be able to have distance here, we have to make this ut plus 1 over 2 at square. Yes. So the distance is u is 0. Everything here comes to 0. You have 1 over 2 times. Acceleration is 2. This will cancel times. T is 4. And the 4 square is 16. S is equal to 16 meters. So the work done is going to be F is 200 times 16. So you said that work done is going to be 2 times 16 is 3200 joules. So we have that in option, 32. Oh, sorry. The force is 20. It's not really 200. That was over 200 is 20. So that is why is 320 joules, and that is option D. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that makes learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that will benefit from it. Bye.